Hello there, welcome back. This is the second part of the PrintShift 4.0 build. First part we installed the belt, motor driving the belt, get the bed sorted out. This video we're going to power the motor such that it will be driven from the printer itself. In order to control it, adding in a micro switch to the top of the Z axis. So this will be mounted basically right there. And then we want to clear the print, raise the Z up, start the motion. There are two ways you can wire up the electronics. One I've been favoring for the simplicity of it are these solder shrink connectors. So if you look close, we have this little red band is an adhesive, this clear tube is heat shrink, and the silver in here is a low temperature solder. So we can take that, snip off the far end, and it'll actually slip right on the legs of our micro switch. So we put a wire on there, we can solder that in place with a heat gun. Now, why would you prefer a heat gun to a soldering iron? You can get a decent quality heat gun for $30. A soldering iron that you'd like in your house would be about $100. This is a $400 unit. Hakko has some hot tweezers which are really cute but certainly not needed for this project. If you have a decent soldering iron that you enjoy using, feel free to solder your connections. If you need to buy something to make this happen, heat gun is going to hurt your pocketbook less. But really, getting a nice soldering iron that's got a temperature readout and good thermal display is going to cost you about $100. I think it's worth it, but it depends on how much electronics you're going to do in your future. Anyways, to mount our micro switch, this guy actually plops right in here. It makes it a little hard to wire and a little hard to get in there with the heat gun because the heat gun will melt the plastic as well as the solder. The other thing you need is 10mm M3 and a screw, and this is a 3030 T-nut. You can only buy these in packages of, more than one. You really only need one for this project, or you could use more to mount the Pi later. You can also 3D print this part and throw in a M3 hex nut and call it good. Bring you over here. This is a post-insert T-nut, so it can slide in and then twist in the slot and lock itself in place. Normal T-nuts don't have this cutout on the corner and have to be slid in from the top or bottom. Just more convenient. The micro switch gets mounted down here, so we're going to screw that on. And I'll pop in there. Hold the switch in place. Simple zip tie just for insurance. But first thing I'm going to do is I'm going to heat shrink and solder these on. We need to draw on our circuit here. Let's look from here because we can see our three components. So the three components in the circuit we're building are the motor, the power supply, and the micro switch. And they're all going to be connected in series. Power supply first goes to the motor. We'll verify the direction first. Then from the other leg of the motor, we're going to go to the micro switch. And from the leg of the micro switch, going back to the power supply. So we need one more wire. I'm going to cut a different color wire, just to make life easier. Wire stripper, random brand off Amazon. Very useful. It even has a wire cutter tucked out in there, which really worries that I'm going to cut myself on it, but I haven't done it yet. In terms of wiring, the motor terminal polarity matters so that we eject in the correct direction. So we're actually going to do that last. I'm going to wire up the micro switch first, and then use the leads that are going to the motor to test out. The micro switch has three terminals. They're labeled common, no, and NC. No is normally open, and NC is normally closed. So we want to mount from common to the normally open. When the switch is pressed, the normally open closes, and the normally closed opens. So that means When the switch is open, we have no current flowing. We press the switch, current flows through those terminals. First thing I'm gonna do, push that wire. Mount the green as the common, because the green is the closest color to ground we have. I like to stick the wire through and fold it. Get this on. It takes a little force to get on there, but the solder, you can actually deform it. Make sure you got good connection. And we're going to hit this with the heat gun just a second. So we have the common. The normally open is in the middle. Well, that's a little rookie mistake. I forgot to put my solder string on there first. I'll do it. If you make that mistake on this one, you can just slide it on from the other end of the wire. Once both of those are in place, hit it with heat gun, starting from the back, making sure that these two little red bands seals the wire, and then getting enough heat to melt the solder. See the solder starting to peek out there. This will stay hot for a good bit, so do be careful. If you get some solder sneaking out, grab it while it's still sort of warm, and then throw it away. So let's feed these wires through first. Mounts in there. You can use your zip tie. I don't really think the zip tie is necessary, but go from the front. This is sort of a make darn sure the switch never falls out. This is going to be mounted to the top of the Z axis, right here. So we've got our T-nut. Or to get the right position, raise this guy up. And we want the micro switch to trigger basically just before we hit physical reach, so I might have to move the printer's name somewhere else. And now you can't read the name. Excellent. But micro switch triggers, that's pretty good. So we're going to take the green guy, put it back into our power supply. And I keep referring to this as the power supply because that's where it plugs into. Hopefully that's reasonably obvious. You don't want to work on electrical connections when they're live if you don't have a real pressing need to. So for now, I'm going to move the motor mount, or move the Z up to trigger the ejection. And then when we add power, we can make sure we wire up the motor in the correct direction. I'm actually going to solder on the motor just because, I don't know, I feel like I should demonstrate more than one technique. I'm going to power the ejection motor on. So I have 5 volts here. Make sure we get it going in the right direction. Alright, so first guess was wrong. Blue wire in the front, yellow wire in the back. I'm gonna grab some heat shrink to make this look nice and clean. So just some black heat shrink on here. Now if I forget to put this heat shrink on, I can't get the other end of the wire off. So it's soldered in place. I'm also going to turn on my soldering iron. One reason you pay extra is because, look, it's ready to go. Beautiful. Step 1, put the heat shrink on. Then snake it through. trying to heat the wire and the terminal equally, and then introduce the solder. So I'm thinking, if you're getting started on this is one of your first electronics projects, get yourself a quality heat gun, use your solder shrink connectors. Later on, you can get yourself a reasonable, you don't need anything this fancy. Nice to have, but reasonable soldering iron, try it out. When I plug this in, kind of stack stuff on the bed. I just believe it's moving. Yeah. So that is the step 2. Right now, this machine is ready to print from a USB drive. Right there, we'll get one. Start a print. Just in case you don't believe me. Alright guys, happy printing.